Right along with exponents, we also want to um, establish a couple more things. First, what we're going to do is we're going to talk about what our goals are for this specific video regarding exponents. So if you remember last time we talked about the product rule and the quotient rule. Well, this time I want you to understand a couple of things. First, I want you to understand why raising anything to the 0th power is 1. And the second thing we want to understand from this lesson is how to use the power rule to make solving math problems simpler. I'll just put solving problems simpler. So write this at the top of your notes before we begin. And as we get started, we're going to answer this first bullet point first. That we're going to talk about raising something to the 0th power. This is probably a rule that was introduced to you before, and you just haven't memorized. But let's take a second. Let's talk about why that is. And we're going to actually use the quotient rule to display that. Here's what I mean. What happens if we raise any number to the 0th power? Well, as I said a second ago, and as you've probably learned, that is 1, and that's a rule that most oftentimes we just memorize. But let's use the quotient rule to actually get an answer that would look like that. So here's what I mean. What if we had a problem that said, what is 3 to the 3rd power over 3 to the 3rd power? Well, you'll remember that this is just, remember, a notation for repeated multiplication. Well, what are we multiplying? We're multiplying 3 times. So that would look like this. I'm going to multiply 3 times on top, and down here I'm multiplying 3 times on bottom. Well, it's very easy to see that when I do that, all of these would cross out. 3 divided by 3 is 1, 3 divided by 3 is 1, 3 divided by 3 is 1. This would be 27 over 27 if we did the math, and that would come out to 1. Okay, so here it's really easy to see that 3 raised to the 3rd power over 3 raised to the 3rd power is 1. Well, what happens when we do this if we use the quotient rule? Well, 3 to the 3rd power over 3 to the 3rd power, that would be the same as 3 raised to the power of 3 minus 3. And clearly we can see that that would be 3 raised to the 0th power, and that, as we said above, that would equal 1. So that's why this is a rule. That's where raising anything to the 0th power equals 1. That's where that comes from. It comes from the quotient rule. And now we can see if we actually wrote it all the way out, it would equal 1. So anything raised to the 0th power is going to be 1, always. It could be x. That raised to the 0th power is 1. It could be a huge number. If we took a big number, put it in parentheses, and that's actually a relatively small number, but raise that to the 0th power, that would be 1. Okay, and that's just a rule that you can have memorized. What about this? What about when we have an exponent raised to another exponent? Let's actually think about what this means in the context of how we're understanding exponents. Remember, exponents is just the repeated act of multiplication. So 2 to the 3rd raised to the 5th power is the same as multiplying what's inside here times itself 5 times. So let's look at that. So that'd be the same as multiplying 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, and then one more, 5 times. And then as you can see, well, this individual expression right here means I'm multiplying 2 3 times. So what we get is if we did this math out, you would have 15 multiplication of 2's. So this is the same as me writing multiplying 2 15 times. And remember, exponents are just the notation for repeated multiplication. That if you actually did this as the product rule, this would be 2 raised to the 3 plus 3 plus 3 5 times. And 3 plus 3 plus 3 plus 3 is, of course, 15. And so let's take this example and then let's turn around and look back at this and let's make a rule about it. Okay? Do we actually need to do all this work to get this answer? And you, of course, know that the answer is no. We do not need to do all that work. We can just look at this and know right away how to get straight to here. Do you see what that rule is? How can we go straight from 2 to the 3rd power, all of that raised to the 5th power, and get to 2 to the 15th? Well, if we take these two exponents right here and we just multiply them together, 3 times 5 is 15. And in fact, that is the general rule. Anytime we have an exponent raised to another exponent. So let's say this was x raised to the 3rd power and all of that was raised to the 5th power like that. Then that would just be x to the 15th. Because of the power rule, what the power rule says is any power raised to the power. If I want to get my eventual final exponent, I just need to multiply these two numbers right here together. And so that is the power rule. So let's take a look at a couple of examples and then we'll be done. Evaluate 3 to the 5th raised to the 2nd power and 4 to the negative 3rd raised to the negative 2nd power. Okay, we'll do this one over here. Well, as we just learned, all we have to do is to multiply those two exponents together. That 3 to the 5th, all raised to the 2nd power, is the same as writing 3 to the 5th times 2, which is 3 to the 10th. And over here, we'll do the same. That 4 to the negative 3rd, all of that in parentheses raised to the negative 2nd power is the same as 4 raised to the negative 3 times negative 2. Negative 3 times negative 2 is positive 6, so that's the same as 4 to the 6th. And when 4 to the 6th, and when we evaluate these two expressions, this is what we get. This is our answer. And remember, what this is we're saying I want to multiply the base, which is 3, 10 times. And here we're multiplying the base, which is 4, 6 times. And then that's the repeated act of multiplication. So I'm going to leave you with this example. I want you to think about this. Once again, I want you to look at it, and I want you to come up with an answer to this question. What is the difference between 2 raised to the 3rd power, all of that raised to the 4th power, and 2 to the 3rd power in parentheses raised to the 4th power? Or is there a difference? So take a second. I want you to think about this. I want you to answer this in your notes, come up with an answer on your own, and then we're going to talk about it tomorrow in class.